Okay ji, Assalamu alaikum. Now, as we have discussed about unweighted and index number in our last lecture, so now we are going to discuss weighted index number. When weights, what are the weights? It is written in the bracket that the relative importance of the commodities. When weights or the relative importance of the commodities are considered in the calculation of index number formula, that is both prices and quantities are considered, such index number are called weighted index number. So when weights or the importance of the commodities are given both in the question, so for that question or for that situation, uh, when we compute the index number, that index number is called weighted index number. Now there are many types of weighted index number, but according to your course we will just study these three index number. First one is Lasper's index number, then Pasch's price index number, and third one is Fisher's ideal price index number. So first we'll discuss Lasper's price index number. It is defined as P naught N. P naught N is generally showing the price index number. So Lasper price index number is equal to summation Pn into Q naught divided by P naught into Q naught. Now this P naught is wherever naught is written, wherever this 0 is written, this means base year, and wherever this N is written, this means current year. So for this formula, base year quantity, which is Q naught, is taken as weight. So weights should remain same in the denominator as well as in numerator. So weights will remain same. So if you see here, leaving the weights, if you see here, so this first pattern is showing the price relatives, and when with price relatives you write the quantities and you take the weights, this become weighted price index number. And for less pair price index number, the weights are the base year quantity, and for this reason this is also known as base year weighted index number. So in question sometimes it would be written that find the base year weighted index number. Lease year will be not written there, just there would be written that a base year weighted index number. So you should know and you should keep in mind that both means the same formula. Okay, now in next slides we will learn how to solve this formula. First we will discuss Pasch's index number. Now for Pasch's index number, this is equal to summation n Pn into Qn divided by summation P naught into Qn. So in this formula, current year quantity, which is Qn, is taken as weights. In previous formula, less pairs, base year quantity was used as weights, and now for this Pasch's formula, current year quantity is used as base. So this is also called current year weighted. Pasch's is also called current year weighted, and less pair is also called base year weighted index number. And the third one is Fisher's ideal index number. So it is defined as the geometric mean of less pairs and Pasch's index number. Geometric mean, we have discussed this in uh, our second chapter about geometric mean. And what was the definition of geometric mean? That it is the nth positive root of and items. So here items are just two. First is less pair and then Pasch's. So we will take square root of less pair and Pasch's product. So here we have put the values of the formula of less pairs and Pasch's both in this Fisher's formula, and after putting the value we get this formula of Fisher's ideal. It is called ideal because it satisfies two theoretical tests. One is time reversal test and other is factor reversal test. So these are two types of tests which are applied on different index number formulas, and Fisher's index number satisfy these both tests, so that's why it is called ideal. So this sentence is very important from paper point of view, especially in MCQs this can occur. So now by solving this example, this would be more clear to you. Once you learn the formula, you can easily solve the question. Now this example number 4.8 you can find on page number 157. Compute Lesper's, Pasch's and Fisher's price index number for the following data using 1970 as base period. So 1970, this is 1970, so the price of 1970 will be the base year price, and the quantity of 1970 will be the base year quantity, and then for 1975 we will compute all these index numbers. So here the different commodities are given to us and prices and quantities. So now how to solve? First, because I have told you before that because we are taking 1970 as base, so this will become base year price, and base year price is denoted by P naught. Then 1975 price will become current year price, so current year price is denoted by PN. Then the quantity of 1970 is representing the quantity of base year, and it is represented by Q naught, and current year quantity is represented by Qn. So here up till here I have just changed the I have just converted them into their representatives, and then after that, according to formula, now for Lesper's price index number formula is summation Pn into Qn divided by summation P naught into Q naught. So we need to find find these two columns. One is P and Q naught, P naught, Q naught. So P and Q naught, we will multiply the values of Pn with this Q naught. So by multiplying 14 by 110 we get 1540, and then by multiplying 42 by 180 we get this value, then 11 by 75 we get 825, and after taking sum we will put this sum here, and for denominator P naught Q naught, so we will multiply this value with Q naught, P naught Q naught. So 12 multiplied by 110 we get 1320, then 40 multiplied by 42 we get 7200, and then after 10 multiplying by this 10 multiplied by 75 we get 750, and after taking sum we will put in formula and we get the value 107.07. The price index number is 107.07. Now for Pasch's, the formula is summation P and Q n divided by summation P naught Q n multiplied by 100. So again we will form two columns. One is P and Q n and P naught Q n. So P n Q n, we will multiply these both and we get this result, and after taking sum it becomes 10,710, and then I have put the values here, and for last P naught Qn, so we will multiply this 12 by 125, then 40 by 195, then 10 by 70. So we get all these values, and after taking sum, it becomes 10,000. So now by putting the values, we the final answer for Pasch's price index number is 107.1. Then we have Fisher's ideal price index number. So for Fisher's, because Fisher's ideal price index number is using the formula of Lespier and Pasch's combined, so there is no need to find another column. We will just take the sum of these columns which we have already computed, and by putting the values we finally get the result 107.1. So almost for these all index numbers, all weighted index number, the answer is almost same. And now for your assignment, you can find this assignment on page number 170, question number 4.13 and 4.15. And I am again saying to you that I didn't get any of the assignment. I have sent you the email ID, so kindly send me the assignment, otherwise your marks will be deducted. Thank you.